You know what? Almost everyone thinks oil is the most important strategic resource. After all, oil crises can plunge the global economy into recession. Oil prices can determine the rise and fall of nations. But reality is far more shocking than this. There's a metal you've never heard of that's quietly controlling everything from iPhones to F-35 fighter jets in 2025. When China's Ministry of Commerce quietly updated what seemed like a routine export control list, the world had no idea that a war capable of reshaping the global tech landscape had already begun. Samarium, gadolinium, terbium, dysprosium element, names that even chemistry students can't pronounce properly, suddenly became more precious strategic assets than gold. An F-35 fighter jet needs 920 pounds of these metals. Your iPhone requires 17 of these elements. And 90% of global supply is controlled by one country. Right now, Detroit factory workers don't know they're about to face unemployment. Silicon Valley engineers are rethinking our entire tech infrastructure. Pentagon generals are discussing a desperate reality. America's most advanced weapons might become impossible to manufacture because of a few missing metals. This isn't an ordinary trade dispute. This is an invisible tech war that will determine who can dominate the global landscape for the next decade. And the outcome might be far more shocking than you can imagine. When China's Ministry of Commerce issued announcement No. 18 of 2025 on that Thursday morning Beijing time, the content looked mind-numbingly boring, implementing export controls on samarium-related items, gadolinium-related items, and 5 other heavy rare earth elements. 99% of people who saw this news would scroll right past it because these chemical element names were just too obscure. But inside Lockheed Martin's procurement department, alarms were already blaring throughout every floor. Procurement Director Jeff Thompson stared at the red warnings flashing on his computer screen, his hands trembling slightly. As the world's largest defense contractor, Lockheed Martin understood better than anyone what this seemingly routine announcement really meant. "This is a complete disaster," Thompson told the Pentagon official on the other end of the phone. Numbers were staggering. An F-35 fighter jet requires 920 pounds of rare earth elements, including massive amounts of samarium and gadolinium. And now the supply of these critical materials had been completely cut off. What made it even worse was that China controlled 90% of global heavy rare earth processing capacity. There were no alternatives whatsoever. The news spread faster than anyone could have imagined. Within 48 hours, global rare earth prices skyrocketed, over 30%. Some rare element futures prices actually doubled. But the price surge was just the beginning. The real disaster was still coming. Daniel Picard, chairman of the Critical Minerals Advisory Committee at the U.S. Trade Representative's Office, later recalled, "This was the most surgical economic strike I've ever witnessed." China didn't deploy troops or fire missiles. They simply adjusted export policies for a few metals and threw America's entire high-tech industry into an unprecedented crisis. Wall Street's reaction was even more direct. Rare earth concept stocks went wild after opening, with MP Materials jumping over 40% in a single day and USA Rare Earth hitting the daily limit. But behind this surge was deep panic. Investors suddenly realized that American tech independence was a complete illusion. Even more shocking data soon emerged. America imports over 15,000 tons of rare earth oxides annually, with 85% coming from China. For heavy rare earths, this percentage reaches 99%. This meant that if China completely cut off rare earth supplies, America's entire high-tech industry would grind to a halt within 3 months. China's rare earth control policies hit like the first domino in a global manufacturing chain reaction. In the second week of May, Ford's Chicago plant announced a week-long shutdown due to rare earth magnet supply disruptions. This facility, with annual capacity for 400,000 vehicles, had to send 3,000 workers home because it was missing a few kilograms of rare earth magnets. But Ford's troubles were just the tip of the iceberg at Mercedes' Stuttgart plant in Germany. Engineers were frantically assessing rare earth magnet inventory for their electric vehicle production lines. The numbers made everyone gasp. At current production rates, their rare earth magnet stockpile would last only 6 weeks. Worse yet, almost no suppliers outside China could provide the high-performance rare earth magnets needed for the EQS electric vehicle. Fiat's Turin plant faced similar troubles. On the production line, 500 horsepower electric motors sat quietly on assembly tables, missing just one critical component or earth permanent magnet motors. Plant manager Luca Rossi told local media with resignation, "We have the most advanced technology, the most skilled workers, plenty of steel and plastic, but we don't have rare earths. Without rare earths, these engines are just scrap metal." Japan's situation was even more dire. Suzuki announced a halt to Swift model production. Honda was forced to delay the launch of new hybrid vehicles. At Toyota's Nagoya headquarters, the board held an emergency meeting. Aki Toyota stated seriously, "We must completely reassess our entire supply chain strategy. This crisis shows us that no matter how advanced our technology, if raw materials are controlled by others, we'll always be passive." However, civilian industry troubles paled compared to the crisis facing the defense sector. The Pentagon's Crisis Response Center 3 floors underground. An unprecedented emergency meeting was underway. Attendees included the Defense Secretary, Chairman of the Joint Chiefs, and CEOs from all major defense contractors. The conference room's big screen displayed a set of devastating numbers. An F-35 fighter needs 920 pounds of rare earth elements. A Virginia-class nuclear submarine requires 9,200 pounds. And Tomahawk cruise missile guidance systems depend entirely on neodymium iron boron permanent magnets. Now, the supply chain for these critical materials was completely broken. Raytheon CEO Greg Hayes admitted at the meeting, "Our Patriot missile systems are heavily dependent on rare earth elements supplied by China. If the supply continues to be disrupted, we may have to halt production." This isn't just a business issue, it's a national security issue. Even more worrying was the time factor. Defense products typically have production cycles measured in years, in any raw material. Shortage could cause delays lasting years. Internal Pentagon assessments showed that if rare earth supplies were disrupted for more than 6 months, America's weapons manufacturing capacity would decline by over 60%. Lockheed Martin's data was even more alarming. The company's current rare earth inventory could only support 3 months of normal production. In the F-35 program, being America's most expensive weapons project in history, would suffer hundreds of billions in losses from any production interruption. While defense, companies worried about rare earth cutoffs. Silicon Valley tech giants were quietly assessing the crisis impact. Apple held a top-secret meeting at its Cupertino headquarters to discuss potential effects of rare earth supply disruptions on iPhone production. Apple's chief operating officer Jeff Williams revealed a stunning fact at the meeting. Every iPhone uses 17 different rare earth elements. From screen phosphors to speaker magnets, from camera lenses to battery catalysts. If rare earth supplies are truly disrupted, we might have to redesign our entire product line, Williams said. Tesla faced more direct challenges. Each Model S requires over 2 kilograms of rare earth permanent magnets, and these magnets currently depend almost entirely on Chinese supply. Elon Musk was blunt in internal meetings. "We keep talking about American manufacturing. But if we depend on other countries for basic raw materials, then American manufacturing is a joke." Microsoft's situation was equally concerning. The company's data centers rely heavily on hard drives made with rare earth magnets, and normal cloud computing operations depend entirely on this equipment. A Microsoft executive told the Wall Street Journal anonymously, "We're evaluating all possible alternatives, but in the short term, we have no choice but to rely on Chinese supply." April 15th, just 11 days after China issued its rare earth export controls. President Trump signed Executive Order 14,272 in the White House Oval Office. This order, based on Section 232 of the Trade Expansion Act of 1962, was dubbed by media as restarting the Cold War playbook. Trump was serious during the signing ceremony. America cannot continue letting our national security depend on handouts from unfriendly nations. Starting today, we're rebuilding America's rare earth industry, whatever the cost. As soon as he finished speaking, Commerce Secretary Gina Raimondo immediately announced the launch of a 180-day emergency investigation to assess threats to U.S. national security from rare earth imports. But even more shocking news was still coming. On July 12th, the Pentagon announced an unprecedented decision, providing MP Materials with $400 million in preferred stock investment and a $1 billion loan commitment, totaling $14 billion in support. This wasn't just financial backing, it was a long-term commitment. The U.S. government guaranteed to purchase neodymium praseodymium oxide produced by MP Materials at $110 per kilogram. With a contract lasting 10 years, this price was nearly 30% above market rates, essentially having American taxpayers subsidize the rare earth industry. But when national security was at stake, economic considerations seemed trivial. The moment the news broke, Wall Street went crazy. MP Materials stock price exploded 48% in pre-market trading, rocketing from $42 to $62, adding over $2 billion in market cap within hours. This once near-bankrupt company instantly became the flagship of America's rare earth revival. MP Materials CEO Jim Litinsky told CNBC excitedly, "This isn't just an investment in our company, it's an investment in America's rare earth industry. Future will prove that America can compete with any nation in rare earths." But what Litinsky didn't tell the public was that even with massive government support, MP Materials still faced enormous challenges. The company's Mountain Pass mine in California had rich rare earth reserves, but had been losing money for the past 20 years. Chinese low-price competition had turned this once world's largest rare earth mine into a hot potato. In early 2025, MP Materials' magnet factory in Fort Worth, Texas, finally came online, marking America's first domestic rare earth magnet production. In half a century, on opening day, Litinsky proudly declared, "We've finally broken our dependence on China." However, when reporters asked about specific capacity, the atmosphere became awkward. This factory, which cost $300 million to build, had annual capacity for only 1,000 tons of neodymium iron boron magnets. Meanwhile, China had produced 138,000 tons of neodymium iron boron magnets in 2018. Simple math showed MP Materials' breakthrough equaled just 0.7% of Chinese capacity, while MP Materials grabbed headlines. Another American rare earth company, USA Rare Earth, began its own expansion plans. This relatively smaller company chose a different path, focusing on small batch high-value rare earth magnet production. USA Rare Earth CEO Leonard Clark explained the company's strategy to Forbes. "We're not planning to compete with China on scale that's impossible to win. Our advantage lies in technological innovation and product customization. American defense and high-tech companies need high-performance customized solutions, not mass-produced standard products." In May 2025, USA Rare Earth announced completion of $75 million in financing, funding a 310,000 square foot neodymium iron boron magnet facility in Oklahoma. Investors included prominent private equity funds and government-backed investment institutions. The company's Round Top mine project was even more ambitious. This West Texas mine site reportedly contained rich, heavy, rare earth reserves and was expected to begin production in 2026. Clark claimed that once the mine reached full production, it could meet 50% of America's heavy rare earth needs. But industry experts were skeptical. UC Berkeley mineralogy professor John Matthews pointed out, "The Round Top project sounds great, but rare earth mines typically take 10 to 15 years from exploration to production. Even if everything goes smoothly, the 2026 production target is overly optimistic." To support domestic rare earth industry development, the U.S. government deployed almost every available policy tool. Beyond direct financial support, federal agencies rolled out tax incentives and regulatory conveniences. The Rare Earth Magnet Manufacturing Production Tax Credit Act of 2023 provided $20 per kilogram in tax credits for American-made magnets, rising to $30 if 90% of components came from U.S. suppliers. This bill was co-sponsored by Republican Representative Guy Reichenthal and Democratic Representative Eric Swalwell, showing rare bipartisan consensus. At the state level, governments competed to attract rare earths investment. Oklahoma provided USA Rare Earth with $15 million in land subsidies and tax rebates. Texas promised $20 million in infrastructure support for MP Materials expansion projects. More importantly, FY 202 for National Defense Authorization Act included a key provision starting in 2028. U.S. military weapon systems would completely ban Chinese-made rare earth magnets. This unprecedented ban essentially created a guaranteed market for American rare earth companies. The Pentagon alone purchases over 2,000 tons of rare earth magnets annually, worth about $1 billion, facing China's massive advantages in traditional rare earth technology. American companies began pushing in two directions, catching up in traditional tech and developing alternative technologies. In traditional technology catch-up, the U.S. government provided R&D funding to multiple companies through the Defense Production Act. Idaho National Laboratory received $50 million to develop new rare earth separation technologies. Oak Ridge National Laboratory got $30 million, specifically for rare earth recycling research. But more interesting was alternative technology development. General Electric announced a $200 million investment in rare earth-free motor technology, trying to reduce dependence on rare earth permanent magnets through innovative reluctance motor designs. Tesla was also secretly developing next-generation motors, reportedly reducing rare earth usage by over 50%. Apple's moves were even more radical. The company announced launching a zero rare earth plan, aiming to completely eliminate iPhone dependence on rare earth elements within 5 years. Apple's materials science team was developing new display and sensor technologies to replace rare earth elements with other materials. Wall Street's enthusiasm for rare earth industries reached unprecedented heights. Since 2025, rare earth became the most sought-after investment targets. The next rare earth ETF doubled its assets under management in just 6 months, reaching $1.5 billion. Individual stock performance was even crazier. Beyond MP Materials and USA Rare Earth, almost every rare earth-related stock saw major gains. Even traditional mining companies could get 20% plus stock bumps just by announcing rare earth ventures. But rational investors began worrying about bubble risks. Warren Buffett's partner Charlie Munger warned at the Berkshire shareholder meeting, "Rare earths are indeed important, but investors need to realize there's a long road from having reserves to profitable production. Many investors may be overestimating the speed of America's rare earth industry revival." Data supported Munger's concerns. Even the most optimistic projections showed America would need at least 10 years to achieve rare earth self-sufficiency. During these 10 years, America would still need imports to meet demand. This dependency set the stage for major stock volatility. To understand the real challenges facing America's rare earth industry, we must go back to the 1980s. Back then, California's Mountain Pass mine was the absolute king of global rare earth, controlling over 70% of world rare earth supply. America had the world's most advanced rare earth mining and processing technology, from Molycorp to Chevron. All major chemical companies had rare earth operations. But everything changed in the 1990s. China entered the market with unprecedented low prices, and rare earth prices plummeted 80% in just a few years. Facing unprofitable realities, American companies abandoned rare earth sectors. Mountain Pass mine officially closed in 2002, marking the end of America's rare earth golden age. The closure lasted 20 years. When MP Materials restarted Mountain Pass in 2017, they were shocked to discover that almost all technical personnel had retired or changed careers. Related technical documents were scattered everywhere. Some key production processes were completely lost. It was like archaeology, recalled MP Materials Chief Technology Officer Ryan Shelley. We had to rebuild the entire knowledge system from scratch. By late 2025, when MP Materials' Texas factory officially came online, the world's attention focused on this historic moment. This was America's first large-scale rare earth magnet production in 50 years, hailed by media as a victory for American manufacturing. However, when specific capacity data was released, the celebration stopped abruptly. MP Materials had annual capacity for 1,000 tons of neodymium iron boron magnets, while according to the U.S. Geological Survey, China's 2024 neodymium iron boron magnet output reached 200,000 tons. Simple calculation showed America's breakthrough equaled just 0.5% of Chinese capacity. Even more depressing data followed. America's annual rare earth magnet demand is about 5,000 tons, meaning even if MP Materials reached full production, it would only meet 20% of American needs. To achieve complete self-sufficiency, America would need to build at least 10 more factories of similar scale. UC Berkeley materials science professor Li Minghua told Science magazine, "The gap between China and America in rare earth industries can't be bridged in a few years." China spent 30 years building their current industry advantage. For America to catch up would take at least 15 to 20 years. If America still had a glimmer of hope in light rare earths, China's monopoly position in heavy rare earths was almost unshakable. China controlled 99% of global heavy rare earth processing capacity elements. It's crucial for high-performance magnets and military products. A classified Pentagon report later leaked showed America currently had zero heavy rare earth separation capability. All terbium, dysprosium, holmium, and other heavy rare earth elements had to be imported from China, though used in small quantities. These elements were indispensable additives for manufacturing high-performance magnets. Even worse, if America began building heavy rare earth processing facilities, the technical barriers were extremely high. Heavy rare earth separation and purification involve thousands of chemical reaction steps requiring extremely precise process control. China had accumulated decades of experience in this field, forming complete technical systems and talent pipelines. Idaho National Laboratory rare earth expert Dr. James Hudson admitted, "We're developing heavy rare earth separation technology. But even if everything goes smoothly, reaching industrial production levels would take 5 to 8 years. Costs would be 3 to 5 times higher than China. Even scarcer than technology was talent." America's rare earth industry had been interrupted for 20 years, creating an entire generation gap in technical personnel. Currently, fewer than 50 engineers nationwide had rare earth processing experience. While China had over 5,000 rare earth technical specialists in Baotou alone to solve talent shortages, MP Materials launched an ambitious talent program. The company partnered with MIT, Caltech, and other top universities to establish rare earth technology scholarships, funding 100 students annually to study related fields. The company also recruited high-salary talent from China and Australia, trying to quickly build technical strength. But talent development takes time. A qualified rare earth engineer needs at least 10 years of practical experience. While America's rare earth companies were still in startup phases, lacking sufficient practical platforms, this created a vicious cycle. No talent meant no production, expansion, and no production scale meant no talent development. Another major challenge for America's rare earth industry revival was environmental regulation. Rare earth mining and processing generated massive radioactive waste and toxic chemicals, causing serious environmental pollution. This was precisely why Mountain Pass Mine closed in 2002, though MP Materials claimed to use the most advanced environmental technology. Local environmental groups still strongly opposed it. California Environmental Alliance Chairman Susan Johnson stated at protests, "We can't sacrifice California's environment just to reduce dependence on China. America has strict environmental standards, which means rare earth production costs will inevitably be much higher than China." Complex environmental approval procedures also seriously slowed project progress. USA Rare Earth's Round Top project, had undergone 3 years of environmental impact assessment and still hadn't received final approval. Company CEO Leonard Clark complained, "We've spent more time on environmental approvals than actual construction. At this efficiency, America will never compete with China, facing massive disadvantages in traditional rare earth technology." American companies began betting on technological alternatives. Logic was simple. Since they couldn't catch up with China in traditional technology, they'd leapfrog to develop new technologies that didn't depend on rare earths. General Electric's rare earth-free motor project exemplified this approach. The company invested $200 million developing reluctance motor technology. Trying to replace rare earth permanent magnet motors through innovative designs, project leader Michael Brown confidently stated at tech demonstrations, "Our goal is developing next-generation products that outperform rare earth motors." Tesla's approach was more pragmatic. The company was developing low rare earth motors, reducing rare earth usage by over 50% through optimized magnetic circuit design and control algorithms. Elon Musk revealed in earnings calls, "Our goal isn't completely eliminating rare earths, but reducing dependence to controllable levels." Apple's zero rare earth plan was most radical. The company was developing new material-based display and sensor technologies, trying to completely eliminate iPhone dependence on rare earth elements within 5 years. Apple's materials science VP Jeff Williams stated at developer conferences, "We believe technological innovation can find perfect rare earth substitutes, but technology substitution wasn't a cure-all." MIT materials science professor Angela Belcher pointed out, "Rare earth elements are widely used because they have unique physical and chemical properties. Finding substitute materials with comparable performance might take decades or longer. And even finding substitute materials, the industrialization process would still require massive investment and time. Even overcoming technology and talent obstacles, America's rare earth industry still faced a fundamental challenge: cost. Due to environmental standards, labor costs, regulatory fees, and other factors, American-produced rare earth products cost 30 to 50% more than China.MP materials. CFO admitted at investor meetings, "Without government subsidies, we simply cannot compete with China. Even with $14 billion in government support, we still need major technological efficiency breakthroughs to achieve long-term profitability." This cost disadvantage wasn't just in production, it extended throughout the entire industrial chain. China had developed a complete rare earth industry ecosystem over 30 years. From mining equipment to processing chemicals, from technical services to logistics, all links were highly specialized and scaled. For America to rebuild such an industrial ecosystem required not just funding, but time and patience. In rare earth industry, globalization. Even if America established domestic production capacity, it couldn't completely escape dependence on China. Modern rare earth industry was a highly complex, globalized supply chain involving mining, smelting, separation, processing, manufacturing, and other links. Take neodymium iron boron magnets as an example. Even if America could produce magnets, it would still need to import rare earth metal raw materials, and 85% of global rare earth metal processing capacity was controlled by China. This meant America's independence was still built on dependence on Chinese raw materials. More complexly, which rare earth downstream product manufacturing was concentrated in Asia. Even if America produced rare earth magnets, these magnets might still need shipping to China for manufacturing into motors and electronic products, then re-exported to America. This complex, globalized division of labor made supply chain decoupling extremely difficult and expensive. While Western nations scrambled to address rare earth supply crises, China was playing a much bigger game. The new rare earth management measures that took effect in January 2025 were just surface phenomena. The real strategic layout went much deeper. China was using the Belt and Road Initiative and bilateral investment agreements to lock up more rare earth resources globally in Africa. Chinese companies already controlled 72% of Congo's cobalt output, 28% of graphite exports, and established large lithium mining projects in Mali and Zimbabwe. These investments seemed scattered but actually formed a complete critical mineral supply network. A China Minmetals executive revealed in an internal publication interview, "Our goal isn't just controlling rare earths, but controlling all critical minerals needed for the entire new energy industry chain." More importantly, was technology export. China was exporting rare earth processing technology to developing countries, helping them build their own rare earth industries. On the surface, this seemed like cultivating competitors, but actually it was building a China-centered rare earth technology ecosystem. Malaysia, Vietnam, Kazakhstan, and other countries' rare earth projects all use Chinese technical standards and equipment, ensuring China's core position in global rare earth industry. Caught between China and America, the EU faced unprecedented strategic dilemmas. On one hand, the EU didn't want complete dependence on China for critical material supplies. On the other hand, it couldn't bear the economic costs of completely decoupling from China. This contradiction led to EU vacillation on rare earth issues. Germany, as the EU's economic engine, was especially conflicted on this issue. German automotive industry was an important driver of global electrification transformation, with growing rare earth demand. Volkswagen Group CEO Oliver Blume admitted at the Frankfurt Auto Show, "We're evaluating all possible rare earth supply sources, but the reality is, short-term we have no choice but to continue relying on Chinese supply." To reduce dependence on China, the EU launched the Critical Raw Materials Act, planning to reduce single-source dependency for critical minerals to below 65% by 2030, but this goal faced huge challenges. Internal EU Commission assessments showed that even mobilizing all possible resources, the EU couldn't reduce rare earth dependence on China below 80% before 2030. More complex were internal EU divisions. France and Italy leaned toward cooperating with America to build a Western rare earth alliance. Germany and the Netherlands preferred maintaining trade relations with China, reducing risks through diversification. These divisions made it difficult for the EU to form unified rare earth strategies. In the rare earth struggle, Japan demonstrated characteristic precision and patience, one of the world's largest rare earth importers. Japan began designification efforts after the 2010 rare earth crisis. Now, these early investments were showing results. Japan's strategy had 3 levels: technology, substitution, resource diversification, and circular utilization. In technology substitution, Hitachi and Panasonic achieved important breakthroughs. In rare earth-free motor technology, Panasonic's new generation electric vehicle motors reduced rare earth usage by 70% while improving performance by 15%. In resource diversification, Japanese trading companies showed super execution in global rare earth resource deployment. Mitsubishi Corporation's Australian rare earth projects, Mitsui's Kazakhstan cooperation, Tochu's Vietnam investments, these seemingly scattered projects actually formed a global rare earth supply network. Most interesting was Japan's rare earth recycling efforts. Japan had built the world's most complete rare earth recovery system, recovering neodymium from waste hard drives and extracting europium and terbium from discarded fluorescent lamps. Sumitomo Metal Mining's recycling plant could process 10,000 tons of rare earth containing electronic waste annually with 95% plus recovery rates. Against the backdrop of China's rare earth competition, some new powers were quietly rising. Australia, with rich, rare earth reserves and relatively stable political environment, was becoming an important link in Western rare earth supply chains. Australia's Lynas was already the largest rare earth producer outside China, with its Malaysian processing plant having annual capacity of 22,000 tons rare earth oxides. More importantly, Lynas signed long-term supply agreements with the U.S. Defense Department. Becoming a major rare earth supplier for American defense companies, Arafura Rare Earths Nolan's project was even more promising. Once operational, the project was expected to provide 4% of global neodymium-praseodymium demand by 2032, though this percentage seems small. Any new capacity was precious, given extremely tight rare earth supplies. Canada was also pushing in rare earth fields. Quebec's rare earth projects received strong federal government support, aiming to become important nodes in North American rare earth supply chains. Canadian Prime Minister Justin Trudeau clearly stated during his U.S. visit, Canada is willing to become America's reliable rare earth supply partner. Facing rare earth supply uncertainties, global tech companies were accelerating technological innovation. This innovation focused on three directions: reduction, substitution, and recycling. Reduction meant reducing rare earth usage through technical improvements. Tesla's new generation motors were typical examples, reducing rare earth usage by half. Through optimized magnetic circuit design and control algorithms, while maintaining performance, Nissan's approach was even more radical. Their latest electric vehicle motors used no heavy rare earth elements, only relatively abundant light rare earth elements. Substitution meant developing new technologies that didn't use rare earths. Beyond reluctance motors mentioned earlier, researchers were exploring other possibilities. MIT research teams were developing new permanent magnet materials based on iron-nitrogen compounds, performance potentially approaching neodymium iron-boron magnets. If this technology could be industrialized, it would revolutionize rare earth industries. Recycling meant improving rare earth recovery and reuse rates. Currently, global rare earth recycling rates were under 1%, with huge improvement potential. New rare earth recycling technology, developed by America's Argonne National Laboratory, could boost recovery rates above 90%, with recycling costs only 30% of new production costs in rare earth struggles. Financial capital was playing increasingly important roles. Wall Street investment banks and private equity funds were massively entering rare earth fields, not only providing financial support, but influencing industry patterns through capital operations. Goldman Sachs established a dedicated rare earth investment fund in 2025 with $5 billion scale. The fund not only invested in rare earth companies, but also engaged in rare earth futures trading and industry. M&A Goldman's commodities chief Jeff Curry stated, "Rare earths will become one of the most important investment themes of the next decade. We see enormous investment opportunities." Chinese financial institutions weren't to be outdone. China Investment Corporation acquired rare earth assets globally. Industrial and Commercial Bank of China provided special loans for Belt and Road rare earth projects. Construction Bank even launched rare earth-themed wealth management products. This financial support strengthened China's control in rare earth industries. More interesting was rare earth futures market development. Chicago Mercantile Exchange launched rare earth futures contracts, providing companies tools to hedge price risks. But this also meant rare earth prices would be more susceptible to speculative fund influence, increasing market volatility. Behind rare earth struggles lay deeper geopolitical logic. Controlling rare earths meant controlling development rights for future industries like new energy, artificial intelligence, aerospace, and defense. This control was far more effective and covert than traditional military deterrence. A report from America's Center for Strategic and International Studies noted, "Rare earths are becoming the oil of the 21st century. Whoever controls rare earth supply chains will dominate global technology competition." This recognition was driving nations to elevate rare earth security to national security levels. China clearly understood this principle. By controlling rare earth supply chains, China gained not only economic benefits, but more importantly, strategic initiative. When America imposed technology blockades on China, China could respond with rare earth controls. This asymmetric countermeasure was often more effective than direct military confrontation. Based on current development trends, rare earth patterns over the next decade might present several scenarios. Scenario 1, China's advantage continues. If America and other countries' rare earth industry development falls short of expectations, China will maintain dominance in rare earth fields. In this case, China could leverage rare earth advantages for leverage in more international disputes. Scenario 2. Multipolar competition. If rare earth projects in America, Australia, Canada, and other countries successfully come online, global rare earth supply will show multipolar patterns. This would reduce dependence on China. It might also lead to price increases and supply instability. Scenario 3. Technology substitution breakthrough. If rare earth-free technologies achieve major breakthroughs, traditional rare earth's importance would decline significantly. In this case, technology leaders would gain new competitive advantages while traditional resource advantages would be weakened. Scenario: international cooperation mechanisms. Facing common rare earth supply challenges, nations might establish international cooperation mechanisms, stabilizing supply and prices through multilateral agreements. This situation would best serve global interests, but had a relatively low probability of realization. When we stand in 2025, looking back at history, we'll discover that rare earth struggles aren't just economic competition, they're power games about future world order. In this game, traditional military strength and economic scale are important, but control over critical resources and core technologies might be more decisive. In this invisible war, there are no absolute winners, and losers, only adapters and those left behind. Those who can find balance among technological innovation, resource control, and strategic positioning will occupy favorable positions in future competition. Those still immersed in traditional thinking might find themselves abandoned by the times. The rare earth war teaches us that in globalization's era, true independence isn't isolation but maintaining autonomy amid interdependence. True security isn't building walls but maintaining competitiveness through open cooperation. True strength isn't controlling everything but maintaining adaptability amid change. This war has just begun, but its results will affect all of humanity's future.